Good morning, children. Now, let us move further in studying the system of resistors and effective resistances. A resistor is, by now you know, that a two-ended component having a given amount of resistance between its two ends. So, in several electrical devices, a number of resistors are connected together in different ways, and Ohm's law is applicable to all such connected resistors. So now let us study resistors in series. You can see that the ends of the three resistors are connected so that they follow one after the other in a single line. These resistors are said to be connected in series. In such an arrangement, the same current flows through each resistor. The value of current is I and the potential difference between C and D, its value is V. The three resistors R1, R2 and R3 are connected in series in the circuit. So now let the voltage across them be V1, V2 and V3 respectively. Then the effective voltage, that is capital V, will become V1 plus V2 plus V3, and if RS, S stands for series, is the effective resistance between C and D, then according to Ohm's law, V is equal to IRS. So the effective resistance between C and D, V is equal to IRS. It will be equal to IR1 plus IR2 plus IR3. Taking I common on both the sides and removing it, dividing it on both the sides, it becomes RS is equal to R1 plus R2 plus R3. This means that when the resistors are connected in series, the same current flows through each resistor, and the effective resistance of the resistors is equal to the sum of their individual resistances. The potential difference between the two extremes of the arrangement is equal to the sum of the potential differences across individual resistors. The effective resistance is larger than each of the individual resistances. This arrangement is used to increase the resistance in a circuit. Do you know, when resistors are connected in series, they are connected one after the another. If any one of them does not function, the circuit breaks and there is no flow of electricity. If two bulbs are connected in series, they will both give less light than if they had been connected individually. If three bulbs are connected in series, their light output will further decrease. What is the reason behind this? In series arrangement, when any one of the resistors does not function, the circuit breaks, hence no current flows further. When two bulbs are connected in series, their effective resistance increases and the total potential difference gets divided across them. Hence, each bulb gives less light as it gets less potential difference across it. When three bulbs are connected in series, the potential difference across the individual bulbs will decrease further, and hence the light output decreases further. Now let us see the solved examples related with the resistors in series. You can see here three resistors having resistances of 15 ohm, 3 ohm and 4 ohm are connected in series. What is the effective resistance? So now effective resistance, we know RS is equal to R1 plus R2 plus R3. So it will be 15 plus 3 plus 4, that is 22 ohm. Next, the two resistors having resistances of 16 ohm and 14 ohm are connected in series. If a potential difference of 18 volt is applied across them, calculate the current flowing through the circuit and the potential difference across each individual resistor. You can see here R1 is 16 and R2 is 14. So effective resistance RS will be 14 plus 16, that is 30 ohm. Now current will be I. So value of V will be V1 plus V2. So it will be 18 volt, and R we have 30 ohm, so 18 divided by 30 is 0.6 ampere. Okay, and V1 is equal to IR1. So I we know is 0.6 and R1 is 16, so 16 6 and 96, so it will be 9.6. IR2 will be again 0.6 multiplied by 14, so it will be 8.4 volt. Now let us study resistors in parallel. Resistors are connected in parallel when their ends are connected at both the sides. As you can see in the figure, here three resistors R1, R2 and R3 are connected in parallel between the points C and D. Okay, they are connected one below the other. So here potential difference is V between C and D. Okay, and let I1, I2 and I3 be the current flowing through the resistors R1, R2 and R3 respectively. So the total current flowing through the circuit is I1 plus I2 plus I3, and here Rp will stand for effective resistance for parallel resistor. So I is equal to V divided by Rp, and I1 is V divided by R1, I2 V upon R2 and I3 is V upon R3. So now if we just we know that current I is I1 plus I2 plus I3, so we'll substitute the values of V upon R for I. So it will become V upon Rp is equal to V upon R1 plus R2 and V plus V upon R3. Now V is common in all, so we can divide it on both the side, and we get 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So if n resistors are connected in parallel, even if one of the several bulbs connected in parallel becomes non-functional because of some damage due to its filament, the circuit does not break as the current flows through the other path, and the rest of the bulbs, they light up. So when several bulbs are connected in parallel, they emit the same amount of light as when they are connected individually in the circuit. So while bulbs connected in series emit less light than when connected individually. So if a number of resistors are connected in parallel, the inverse of the effective resistance is equal to the sum of the inverses of individual resistances. In case of series, it was the sum of individual resistances simply. Here it is the inverse, that is 1 upon R. The current flowing through an individual resistor is proportional to the inverse of its resistance, and the total current flowing through the circuit is the sum of the currents flowing through individual resistors. The potential difference across all the resistors is the same. The effective resistance of resistors connected in parallel is less than the least resistance of individual resistors. This amount is used to reduce the resistance in a circuit. Let us go through the solved example. Resistors having resistance of 15 ohm, 20 ohm and 10 ohm are connected in parallel. What is the effective resistance in the circuit? So we know the formula for parallel. It is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So it is 1 upon 15 plus 1 upon 20 plus 1 upon 10. So the answer you get is 4.615 ohm. Second example. Three resistors having resistances of 5 ohm, 10 ohm and 30 ohm are connected in parallel, and a potential difference of 12 volt is applied across them. Obtain the current flowing through the circuit and through the individual resistors. What is the effective resistance in the circuit? So for individual resistance, you'll have to calculate by individual formula. I1 is equal to V upon R1. Similarly for R2 and R3. And we have got the values. For effective, the total current, it is I is equal to I1 plus I2 plus I3. So it is 4 ampere. Now we have to calculate effective resistance also. So 1 upon Rp will be 1 upon 5 plus 1 upon 10 plus 1 upon 30. So it will be 1 upon 3. So the effective resistance in the circuit is 3 ohm, and current flowing through the resistance is 5 ohm, 10 ohm and 30 ohm is 2.4 ampere, 1.2 ampere and 0.4 ampere respectively. and the total current flowing through the circuit is 4 ammeter. Domestic electrical connections. The electricity in our homes is brought through the main conducting cable either from the electric pole or from underground cables. Usually there are 3 wires in the cable. One is called the live wire, which brings in the current. It has a red or brown insulation. The other wire is neutral wire, through which current returns. It is blue or black. And in India, the voltage difference between live and neutral wires is about 220 volts. So both these wires are connected to the electric meter through a fuse. Through a main switch, they are connected to all the conducting wires inside the home so as to provide electricity to every room. In each separate circuit, various electrical appliances are connected between the live and neutral wire, and the different appliances are connected in parallel. This is also important. Why not in series? Because if you connect in series and even if one is not connected, you know what had happened. If one of the bulb goes off or one of the resistor goes off, or the other bulbs they do not light. But in case of parallel, if one of the bulb is not working properly, the other bulbs will still glow. So that is why at home the appliances are connected in parallel, and the potential difference across every appliance is the same, that is 220 volt. The third wire is called the earth wire, and it is of yellow or green color, and it is connected to a metal plate buried deep underground near the house. It is for safety purpose. Next, fuse wire. Fuse wire is used to protect domestic appliances. It is made up of mixture of substances and has a specific melting point. It is connected in series to the electrical appliances. If for some reason the current in the circuit increases excessively, the fuse wire gets heated up and it melts. The circuit gets broken and the flow of current stops, thus protecting the appliance. This wire is fitted in a groove in a body of porcelain, as is shown here, like non-conducting material. And for domestic use, fuse wire with upper limits of 1 ampere, 2, 3, 4, 5 and 10 ampere are used. So you must have observed at times when light goes off at home, current goes off. First of all, we find out from the other houses, if at their home the current is there and only we do not have the current, then what do our parents do? They first check the fuse. Okay, and what happens to the fuse? If at all there's a lot of fluctuation in the current flowing, at times a lot of more than the required amount of current is flowing, then this fuse wire has a specific melting point. It will melt and it will break. So the current will not flow through it and the circuit will stop and the current will not reach the appliances in the house, and so we say that there is no light. It is for the safety purpose, that the appliances should not get damaged because of the large current that is flowing. Precautions to be taken while using electricity. These are very important. Electric switches and sockets should be fitted at a height at which small children cannot reach and put pins or nails inside. Plug wires should not be pulled while removing plug from its socket. Before cleaning an electrical appliance, it should be switched off and its plug removed from the socket. This is very important. Always be alert that whatever cleaning is going on, remove the socket. At time, our parents also tell us, especially in coolers which have got water, which is a good conductor of electricity. So while filling water in the cooler tank, switch off the cooler, remove the plug from the socket. So one's hand should be dry while handling an electric appliance, and as far as possible one should use footwear with rubber soles. This is important because it is a bad conductor of electricity. So as rubber is an insulator, it prevents the current from flowing through our body and thereby protecting it. So if a person gets an electric shock, you should not touch that person. You should switch off the main switch, and if the switch is too far or you do not know where it is located, then you should remove the plug from the socket if possible. If not, then you should use a wooden pole to push the person away from the electric wire.